Hi students, and welcome to the second part of lesson 4. So I've got one more example I'm going to go through with you today, and this is all to do with creating an equation of a line, but it's in a wordier question, a little more practical context. So what's the question? Well, a sports scientist is looking at data comparing the heights of athletes and their performance in the high jump. The following table and scatterplot represent the data they have collected. A line of best fit by eye has been drawn on the scatterplot. Choose two appropriate points that lie on the line of best fit and determine the equation for the line. So this graph here, the dots are my raw data. Someone has gone in and drawn a line through it. Now I've circled those 2 points and we'll come back to that in a second. But I'm sure we can all see that there's a bit of an association here. It seems that basically the taller someone is, the higher they can jump in high jump, which is kind of what we'd expect. So we need to find an equation for this line. So to do that, it tells me to choose 2 appropriate points that are on the line of best fit. So I've chosen this point and this point, those 2 points that I've circled. Sorry, let's try it again, this point here. So I've chosen those 2 points. So I figured out that that's these 2 points in the raw data. So we can see that this point up here is almost 210, so that's this one here, 208, 193, and this one here, well, it's a little over 190, so it's this one here, 193, oh, yeah, 182, 193. Whoopsie, reading it the wrong way around. Anyway, so basically, guys, the rest of this question is just what we were doing before. We have 2 sets of coordinates, 182, 193, and 193, 208, and it wants us to determine a line of best fit. So, first, I write my gradient formula. Then, I substitute, well, my second y coordinate is 208, my first y coordinate is 193. My second x coordinate is 193. My first x coordinate is 182. 208 take 193 equals 15. 193 take 182 is 11. So my gradient is 15 over 11. So at the moment, my equation is looking like this. Y equals 15 over 11x plus c. So I'm going to sub in the first coordinate to find the value of c. So here's my equation. I'm going to replace the letter x with this x coordinate, 182. I'm going to replace the letter y with this y coordinate, 193. As you can see, I've done here. I then multiplied 15 11ths by 182 to get me this figure here. I went with a decimal because in a fraction form it is a bit ugly. If you try that in your calculator yourself, 15 over 11 times 182, you'll see what I mean. Sometimes decimals are the better way to go. Anyway, so I moved the 248 to the other side. What's the opposite of positive 248? Take away 248. So 193 take away 248 is negative 55.18. So C is equal to negative 55.18. So I write my final equation. Y is equal to 15 over 11x, take away 55.18. Now, I've included this down here. Answers will vary slightly, because those of you who are really keen studiers will note that my solution here does not precisely match what is in the textbook. The reason for that being, guys, if we look at the graph over here, I chose these 2 points. Now, I could have picked this point, and I could have picked this point. I'm eyeballing it off the graph, so it is hard to determine a precise figure. So your answers are going to vary slightly for this one. But just make sure you pick 2 points that you can easily read, and that'll give you a rough idea, or at least it'll give you the best answer you can possibly hope to get. Okay? So, anyway, students, that's the end of the examples for lesson 4. I hope you got something out of them. You know the drill. From this point, looking at the exercises on OneNote, completing them, checking the worked solutions, also available on OneNote if we need them. Have fun, guys, and I will see you for lesson 5.